Hello. So, hi, my name is JJ Asgar, and I am going to be streaming some LinkerD today. If you haven't seen, this is LinkerD on the right-hand side right here. It is the service mesh for Kubernetes. It's one of the three that are kind of in battle to get namespace and recognition inside of our industry. There's LinkerD, there's Istio, and I am completely blanking on the third. And basically, I've never had a chance to sit down with LinkerD, so today I'm going to go ahead and go around and do it. I've gone ahead and spun up a Kubernetes instance, as you can probably see right here. And it is it's just a 3-node cluster from the IBM cloud. And it looks like it's in a healthy state, which is what I was verifying just before starting this stream. And I am going to be installing LinkerD. Luckily, LinkerD has some really awesome documentation, which allows you to kind of just play around and get it up and going. So my goal is to be able to do that and then move along and probably do some more of the advanced stuff that pulls together. Hopefully this will be educational for everyone. And also hopefully it'll be educational for me because, I mean, honestly, I have not done this before and this is me live trying to figure it out. So if you're watching, thank you. And hopefully we'll learn something together. All right, so we are going to go ahead and get anything. We need a Kubernetes cluster, as it says here in step 0, to 112. We are actually running 113, which is good for us. And then I have kubectl installed. So let's just go ahead and run kubectl get nodes. And as you can see, we have this cluster was spun up about 10 minutes ago. Oops, and I will be back in just a moment. Wow, I'm so sorry about that. I've got completely thrown off, and let's start over. Hence again, the starting soon. Yes, hi, I'm JJ Asgar, and today I will be playing around with LinkerD. It is a service mesh for Kubernetes. It's written in Rust, and it is super lightweight and super fast. There's a handful of service meshes out there now. Not including or not limited to LinkerD and something called Istio, and I believe there's a third one now. So I've spent a lot of time in the Istio community. I've even committed to that project, but I've never had a chance to sit down and actually play with LinkerD. So today we're going to sit around and play with it and kind of understand what's going on. If you're wondering what a service mesh is, it is just basically a way for you to roll out your microservices in a more intelligent manner. Intelligent might be the wrong word. More safe manner. You'll be able to put in. Let's say, for instance, you have your typical 3-tier app. You know, your web server, front end, your application stack, and your database. Well, in Kubernetes, you might throw in a handful of other services. That application layer might be a bunch of little microservices that talks to different APIs, and different APIs talk to one another. Using something like a service mesh allows you to intelligently route portions of that code to the different levels of those different little applications. So if you have like an API that gives you back the correct time, right? Like there's a famous JSON API that just gives you back the time that is on that machine. If you needed to switch out 10% of your traffic to do the time and date, for instance, then you could use something with a service mesh to be able to do that. Because it is a proxy for all these different applications and microservices, you actually start getting some really useful information out of it. You get some really cool graphing, you get some really cool just information to be able to understand the health of your system. Luckily, and the one we're playing with today, LinkerD, is so stripped down and actually built on something called a programming language called Rust that allows us to it allows it to be extremely fast and extremely low level. So let's go ahead and start playing around with it. One of the best things you probably can see for anything is just, wow, LinkerD just works. That's a pretty high bar right there. And it really is truly, from what I've read, really truly ultra light and ultra fast. It is very simple and straightforward, and it's supposed to install with zero configuration, which is exactly what we're looking for. And then I'll walk through the tutorial a little bit more. Okay. So, as I told before my little break, because I had a package be delivered that I wasn't expecting, I do have a Kubernetes cluster up here running with version 1.3.8 on IKS, and I have a 3-node cluster to be able to play around with stuff. So let's go ahead and take a quick look at the architecture here. And as you can see, what I was just kind of discussing a moment ago, this is the architecture in a much better description of how the proxy, the LinkerD proxy, sits with the application here. So with LinkerD controlling the service mesh, this would be our application stack. So this would be that 3-tier app or whatever. And then the LinkerD proxy sits here inside the pod and then gives you a bunch of really useful information. As you can see, we get a Prometheus instance for free. And then we even get Grafana graphs off the side of it. We'll be able to even go ahead and, with this controller, be able to tell the LinkerD proxy what percentage or how many of the applications that we need to run to be able to do the work with it, which is pretty cool. You'll see that it looks pretty close to what, if you have any knowledge of Istio, it looks pretty close to it because it's a winning architecture. It's exactly how it's supposed to be done, which is great. So let's go ahead and take the next step. All right, so when you're ready, make sure the recent version is using Kubernetes with this. Client version and server version. All right. So if this is the first time of me running LinkerD, you'll download the command line CLI on your local machine. The CLI, okay. So let's go ahead and download it. Curl sh, got a way of doing it. Pulling it down, and we look like we've just installed it. Go ahead and add that to my path. And then run the pre-check. Something didn't like. They're running the minimum kubectl version. Alright. So I need to update kubectl. Which kubectl? Alright. Update kubectl. Do. So we can go back to LinkerD. Oh, I didn't do that, did I? LinkerD. Version 3? Was it? No. 3. Check. So LinkerD check -- free. No, still didn't like that version of kubectl I installed. Oh, because I hadn't actually moved it. Alright, so mv kubectl to which kubectl? So mv kubectl sudo to there. And then path free. There. Oh, no. What am I doing wrong? Kubectl. I'm already having issues here. Kubectl. Kubectl. Let's try this again. Okay. Something is broken. Let's figure that out. This terminal. New one. Cluster. Okay, get nodes. Short. Which kubectl? User local bin kube. Okay, so let's w curl this back down. Okay, and then try kubectl. Change mod. That's my problem. I didn't change modules, did I? Kubectl and move kubectl to user bin kubectl sudo. And then kubectl version - short. There we go. Okay, now we're running a newer version of it, and it's what I was expecting to do. Okay, so if I do check now, path check now. There we go. Now we're getting green check marks across the board. Okay, cool. So if you didn't catch exactly what I did, I'll just go over that real quick. The version of kubectl, which is the main configuration, the way you configure a Kubernetes cluster, was running at version 1.11, I believe. And then this one, LinkerD, requires at least the correct version of kubectl. So I went ahead and updated it, but I did not change mod it, execute, so I wasn't actually able to execute against it. So then I went ahead and updated it, create the path again, and then ran the pre-flight checks again. So then we can do the LinkerD version here, and as you can see, LinkerD's version is unavailable on the server because we haven't actually installed it. But we do have the stable 2.4 version, which is brand new and awesome. So we're getting somewhere. And as you can see here, you should see server version is unavailable. This is because you haven't installed the control plane in cluster. Okay. So then we validated our cluster, which is what we did here. Now you can have the CLI crossing locally. The cluster is ready to go. It's time to install the lightweight control plane and its known namespace of LinkerD. So if you want to see, I can do kube get all or get all dash dash get namespaces. As you can see, these are all the namespaces that I have. IBM creates a couple namespaces to do some stuff. Default is usually where you throw everything when you have only one person using Kubernetes cluster, and then these are the actual systems. So we're going to create our own, a new namespace called LinkerD, and then we're going to use kubectl apply -f to do this. And off it goes. So this is doing all the creation and installing everything we need to do. And let's see here. There we go. And as you can see, just because I like seeing graphs, here's Grafana being installed, creating a service and everything. So let's go ahead and check out those namespaces again. And you can see here, LinkerD was what we wanted to. So we can do k get pods -ns equals LinkerD. No. I can never remember this name space. There we go. And as you can see here are all the pods. I'll make this a little easier for people to read. All of the namespaces inside of LinkerD and all the pods that are running what we're expecting. So we got our controller, Grafana, identity, Prometheus, the proxy injector that actually injects us into the each of the pods. I'm assuming the web front end. I'm assuming that's a tap interface, so we can probably create an extended. Ooh, that'd be cool. And I don't know what this SP validator is. So that looks good so far. And then we can do LinkerD check. And we are checking everything against it. And the API, control plane version, everything looks healthy. Okay. So then we'll go ahead and do this guy. And we are looking at the statuses of each of these, and everything is ready and up to date. This looks good. So we should be able to see the dashboard now? Oh, cool. So what it did is automatically just creates a proxy, a local forwarding proxy to 507550, which is, I'm assuming their dashboard. And then we even have a Grafana. Oh, so we're already seeing inside of it. That's cool. That's really cool. And then if I take this guy, I should be able to see the Grafana dashboards. There we go. So we are actually seeing real Grafana dashboards with real work through all of these machines. This is really cool. Okay, so we now have observability inside of our data, inside of our cluster, and we also have a dashboard to be able to see statuses of things, which is good, and we can talk to our cluster if we need to. Okay, let's keep going. So it seems if you see here, that creates a port forward to the LinkerD web pod, like I was saying earlier, which is part of the web front end. And you can actually expose this dashboard to everybody if you want to. I don't feel like that's something I'm going to be doing here and right now. For fun, let's just take a look at the steps. So we create a simple ingress with Nginx here. Looks like an authentication token. Creates an ingress. So we'd have to create a host for the basic auth using admin. Okay. Also use traffic if you wanted to. It's straightforward. But being that this isn't actually in the real world, I'm doing it myself. Well, hello there, nibs. This has been surprisingly easy to set up, and we already have LinkerD up and running, with graphs already being created, which is very surprising. I was expecting to spend a lot more time doing this, but that's all it really is. So let's go ahead and keep going here. Okay. So if we run this command, we'll be actually looking at the traffic going to itself. Okay. So if I go back to this and then refresh it, and then click around a little bit, top routes, tab, overview, service mesh. This is actually the conversation that it is having to itself, which is pretty cool. All right. Sorry, give me 2 seconds here. All right. So press Q to quit. Now we are going to install this demo app. To feel how it will work on your services, you can install the demo application. Install it in its own namespace. Okay, let's actually take a look at this YAML file before we just run it. You know, you should probably look at stuff before you push it out onto the internet, right? So what I'll do is I will curl this right here, copy, paste. So what is this doing? This is creating a namespace called Emoji Voto. Creates a service account, then creates a service. Here's the actual image that's being created. I'm curious, did they put that out on GitHub? GitHub, BOYANTIO. Okay, Emoji Voto. Here's the actual application. I'll make this a little bit bigger. Okay. And traffic generator, web emoji for voting. All right. So version 8. It's interesting that they have that version number hard-coded into their install docs. But it seems like, oh, it's a gRPC application. Okay. And it's pretty straightforward. It's Go application, what it looks like. Can I help them out on their Docker file? Because normally these things are challenging. And no, that looks right. Docker file base, Jesse Slim, installs a bunch of stuff. Unix utils, GQ. I don't actually know what that is. Curl, okay. Even has a Docker compose. Probably run this on their local machines. Okay. Make file. Looks pretty straightforward, which is pretty cool. I applaud Buoyant's ability to put some straightforward code out there. Nothing too crazy. Okay, let's keep going. Alright, so we're going to copy this. We're going to paste this in here. And this should install our bunch of namespaces. There we go. And created the pods. Alright, let's port 8080. So 127. That's 0.0.1. Port 8080. Here is our emoji vote. Tap for your favorite emoji. Pizza's always good for me. Alright. Let's do a donut. Oh, that's cool. Quite a bit of traffic already happening, which is good. So as it says here, if you connect the donate emoji, you will always get a 404. Alright. So now that we actually have it up and running, let's go ahead and stop the port forwarding. And then we don't have LinkerD attached to it yet. So that's what we're going to do right here. We're going to inject LinkerD into this deployment. So get the deployment. Let's actually see what this does. So here's the actual deployment from the Kubernetes cluster, and then we LinkerD inject. So this command injects itself into a resource file, and then if you notice here, this goes for all the namespace, the default namespaces, but because we put emojivoto in its own namespace, -n emojivoto, so we are actually injecting it specifically into the emojivoto namespace. So you can actually play with this in a safe manner, which is kind of cool. Alright. So put that in there. Off it goes. Okay. This command retrieves all the deployments running emojivoto namespace through the manifest and applies it to the cluster, just as I was expecting. The LinkerD inject command adds annotations, part spec, instructing to inject this data in proxy point. Continue. Okay. As with install, inject is pure text operation, means you can inspect the output by seeing it. Once piped into kubectl apply, Kubernetes will execute the rolling update on each pod and proxies by downtime. Congratulations, you now have LinkerD to your existing services. Just as with the control plane, it's possible to verify everything worked should data point by running by this command. Everything seems connected. I see a lot of green check boxes, which is always a good sign. Alright. Now, you can view LinkerD dashboard and see all the service in the demo app. Once the demo app comes, the world generator, traffic matches like this. Okay, so let's see real time. So this is actually the load generator talking to it. So if I come back over here, I should be able to see quite a bit more. Ooh, quite a bit more data going through this thing now. So here is the request volume. There is the success rate. Emoji Voto was having a bad day right about then. And the request volume. So we're actually managing to. Wow, that was surprisingly easy to get this information. Let's give this a second and see how it goes. Okay. What other information do you have for me? So this is the actual pod information. What's going on to the actual pod, which is interesting. So this is how it's all connected. Interesting. All right. See the deployments now. I don't actually know what this RPS stands for. Doesn't mean anything to me. Okay, so let's go back to that top image. Top line. Discard. So this is what you would put up in your data center or your whoever was trying to see what's going on. And then when things started breaking, you would see stuff change. So it is actually monitoring itself, which I think is interesting. I don't think you want to do that in the real world, though. And it looks like it got stuck. Let's check out that tap now. Well, first of all, let's see that stat deploy, see how it changed. This does not really tell me anything that I already don't know. Oh, it stopped running the bot, it seems. Is that right? Oh no, it's still going. So, history. So if I want to see it again, how did I see it? There we go, that's what I was looking for. it seems that our bot really likes 7. Okay, so we now have a working instance of LinkerD. We can manipulate, get data from Nginx now, or it's not Nginx. Like we can get data from LinkerD through the service mesh and actually be able to see real traffic happening. Looks like it hit something a few too many times. The voting failed. Luckily, the website's always up though. But the other APIs, the web and no. I guess the emoji is the website, maybe. I don't know. Oh, RPS must be requests per second. Okay. Got it. And this is actually the namespace of LinkerD. So if I put another namespace in here, it would actually tell me more. What else do we have? See what the health of LinkerD looks like. What is that information? That is not very helpful, is it? That's fine. I think I probably broke something. So this should give me some more information now. So you can see it's meshed now. Our voting is having issues, but that's expected because we have those errors happening. And then this feels like that same data point we were going back with earlier. There we go. So this is our deployment of voting. Actually walking through everything, seeing how it goes. Okay. All right. Okay, so that's really it. I didn't really change anything around though. Like I can change the versioning. Here we go. So let us play with a Ruby application that helps us manage our bookshelf. It contains some multiple microservices in JSON over HTTP. If you don't know, Istio.io has something almost exactly the same called book info. If you look right here, excuse me, this is the book info application. It truly is one of the better ways to finally understand why you would want to do a microservices or using something like Istio to do this. But already comparatively speaking, Istio is significantly heavier weight, though there's a lot more knobs and dials you can turn with Istio compared to what seems with LinkerD right now. LinkerD seems very like streamlined and very straightforward, while Istio is much more like a significantly higher coverage of different ways of doing things. Yeah. Granted, I haven't actually used a real production application with this yet, which is something I should probably really do and see the differences between them. But again, this is the big info app. This became a quintessential way of describing service meshes. So it seems LinkerD came up with something along the same lines. As you can see here, this is already significantly easier to understand than this, where Istio has a Python app, and you manipulate these 3 different reviews, this Java app, and then where this one, oops, it seems this one is just a way to manipulate something in here. Okay, so let's go ahead and create the namespace. kubectl create namespace book app, and then we curl down a YAML, and then we inject it into that namespace. After it's done, we'll take a quick little look at this YAML. Curl YAML. As you can see, here's the deployment. It pulls down the version of book traffic. That must be the traffic creator. This is the actual Radiance Pro ping. Yeah, this must be the actual app. And then the author site in the database uses MySQL. Okay. Yep, that is the actual app. And then this is oh, it's 3 different deployments? Okay. Alright, cool. Out of curiosity, I want to see what's going on over here. So we come back over here. Books app. Books app. Books app. Alright. Nope. That's a typo. I'm one of those people who tries to get the easy PRs in for people when I see errors inside of readmes and stuff. Just because, you know, it's nice to have it. Where was it? Wait. That's weird. Duplicate. Why didn't that show up properly? Book app. Curl empty. Chaos monkey. Get app. Run bash. Copy. That should be fine. Why did not... Huh. That is really weird. Bash, 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 bash. Use the app, deploy, run. Why did that not format properly? Alright, so if I come back over to book app, let's take a quick aside. Check out IBM Street. So we'll go ahead and copy this, this down, book app, checkout, -b, ggnsgar, edits, readme. Ooh, readme. Bring up Emacs. Hopefully y'all can read what I'm seeing now. Okay. Bash, 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 bash. Bash, 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 bash. Chaos monkey. 3. That looks right. What do those dashes do? I've never seen that before. Oh, it's a line. Alright. So maybe above this. Same thing here. I don't think it likes that line. Just private buffer. Let's see here. Paste and go. Still doesn't like it. What the? What is going on? It doesn't like anything. Then all of a sudden it kicks in again. Running locally. 2. But service profiles doesn't like it either. What is... You know what? Maybe... Alright, so GitHub is being dumb. Maybe it'll work better this way. Hey there, Mofi. So, in the beauty of open source software, what I'm doing right now is I'm trying to put in a PR to fix the README, because it seems the README's formatting is all jacked up. So that's what I'm doing. Right now, getting LinkerD up and running was surprisingly quick and easy. And then they gave me a new app to play with. And we are getting to the point where I'm trying to understand the app a little bit more. If y'all have any questions or thoughts, or I am more than open to it, because this is me just trying to learn and help out the community right now. Oops. Good old bundle. Yeah, Mofi, it is actually pretty impressive. It is significantly lighter weight than Istio. Already, Istio comes in with so many more things now, where LinkerD just seemed to just get up and do its job. and I'm very, very impressed with it. But as I was saying earlier, it feels like I need a production app or something like that to run with it to really put my 2 cents behind it one way or the other. All right, let's see if this looks any better. Honestly, the setup of getting it up and running was significantly easier. The difference between Istio and LinkerD, the setup seemed so much easier and so much more straightforward. I didn't have to think about it. It just started working. And then also, it just seemed cleaner. I guess the best description is it just seems cleaner. It felt like it was more thought out, put together. Well, Istio is, both of them are open source projects. Istio has one smaller startup that takes responsibility for it. Or sorry, LinkerD does. Well, Istio is a conglomerate between 2 or 3 major corporations, and the way of seeing, how major corporations work together compared to one small startup focusing on one application, it really does feel that LinkerD is just a little bit better thought out and just seems to it feels better to use. I don't know how to describe it so far. It's not so scatterbrained, I guess is the best way to say it. But once again, that's just me kind of playing around with it for 15-20 minutes. And I'm trying to get that one going. But as you can see, by me editing and changing all this formatting now, I've got that fixed. So that's a good sign. Oops. So if I go ahead and fixed some formatting due to markdown, it seems dash at 4 spaces, pause the markdown renderer to have the dash at the top of the line. This fixes that. Renderer, renderer. That's not a word. Let's do it that way. All right. Fork. No. Hub fork. So if you use GitHub at all, you should be using Hub. Hub makes life so much easier. Push. Asgard. It gives you some really simple commands around Git to allow you to do some PRs and things very straightforward, like git push HPR. And you can even edit pull requests just like this in your command prompt. So now I have a pull request open. As you can see here, oops, that totally didn't come up how I wanted to. Maybe that'll work. No. Maybe that. There you go. All right, so that was fun. We now have a PR into this Books app, which is cool. Surprised I don't have any CI or CD against it, being that so many people run with it. Do they even have tests? That was a good question. git checkout master. Do I still have my prep Ruby? I don't. Uh-oh. Made it angry. New window. Close. New window. Alright. Trying here. Sorry, it's taking me a couple seconds here. Let's see, repo. Book. App. Rake-t. Bundle. Let's go ahead and install some. There we go. I should have used something else. Oh. Yeah. I'm not gonna build all that. That's not worth my time. I'm not gonna build Ruby from the ground up here. See how it goes. Let's go back to the actual Alright. So, it's interesting that there is no tests for this. Let's look at the rake file real quick. So, if you don't know anything about Ruby, the rake file is basically the first entry point into an application. So, so this is really the main entry point to talk to your application, or the actual Ruby application. As you can see, there's some there's some tasks that you've got to do. For instance, talking to the database and building it. Then they create namespaces to allow you to do, like, specifically building up your web application, building up your development app, and your books app, so your book, author, and web app here. And then there's even a production namespace too, which allows for that kind of stuff. So Rake alone is extremely powerful. And if you ever do any, if you imagine, Rake is basically make for Ruby. I strongly suggest spending some time with it. It takes a little while to get your head wrapped around it, I'm not going to lie. But as soon as you do, it's one of those things that you can just pull in great things with Ruby to make your lives much easier. Okay, so we have successfully put our PR in, and that is done. So let's go back to our actual application here. So if I go to here, get nodes, am I still logged in? I'm not. So let me log in real fast. Yes. Copied and paste and create the correct account. And then if I do path LinkerD check, I don't have my thing set up properly. Kube config. Okay, get nodes. There we go. So now if I do LinkerD check, there we go. So because I closed my window because I was trying to fix something, I lost my paths, as you saw that I fixed my path, and I also had to recheck some other stuff, but we are now back up and running. So forward. No. I have to come back and figure out what that one was. Okay. So if I do get name space, get namespaces, here we go. And we already need to create a bug app one, and we did. And we checked all that. Cool. So if I do get pods dash name and book app. There we go. So we have, for the last 20 minutes, we've had our app up and running. We have 3 different web apps running, all the same build, if you notice. So it's 3 web apps, the traffic creator, the books, and the alpha. So just like we were seeing up here, the traffic here, the web apps of 3, the authors, and then the books. Cool. All right. Downloading a bunch of containers for just a good while. Kubernetes will tell you all the services running. Wait for that by happening. This guy. It was successfully rolled out, which is what we were expecting. Okay. And then we can do a get all to see everything inside of it. And I'll make this bigger again so everyone can see. As you can see, we get all. Here are all our pods. Here are all, and we even created a load balancer here. So we can actually go to this IP. Oops. Ah, too many windows. Too many windows. This IP. And go to 169.62.39.210 port 30800. Here we go. So we actually have our book app on the internet right now. So if you're actually watching the live stream, and I'll put it in there, that is our actual application up and running on the real internet, which is pretty cool. I'm actually happy that it actually created everything how I expected it to. So as you can see, we got some books. Everything that we should expect. Now we can actually do local port forwarding also here. So if we go to 7172 excuse me, port 7000, we'll see the exact same information that we saw right here, because we are proxying through our local machine, and this is coming out through the real internet. So Mofi just asked, if it's an external IP, why do we still need a port? Well, that's a good question, Mofi. So the short of it is, we use something called a node port here, where we are directly connecting to a specific container, and we've matched them together as one. As you notice, this number is super high, 30,800. That smells, and I should actually look at the deployment personally, but it smells like a node port. And we don't have a something like Nginx in front of it, or something like that can tell your web requests to go to port 7000, as you see up here with our local proxy here, to be able to go to it. So what we've done is we've told Kubernetes and told LinkerD to take those ports and manipulate it that way. In the real world, you'd want something in front of that even more, so you can go farther deep, around, if that makes sense. Did I miss that? It is. Oh, you're right. Haha. I should be looking at my screen. You're right. It is at the type of a load balancer. So yes, I was wrong. That is not a no port. That is a type load balancer. So because it's probably load balancing through these different three web apps, which is interesting. Yeah. Why is that such a high number then? That is really weird. Let's look at the deployment, shall we? Okay. So if I do so Mofi asks, like in SEO, we have an ingress gateway, anything like that in LinkerD? I don't know. We are discovering this ourselves right now. Okay. So you get ebook. So let's take a look here. All right. So load balancer. So here's our load balancer service definition from here to here. Interesting. Is that it? Load? That really is it. Why is it such a high number then? Creates one replica of the first. That's how it's all locked up in the back. I really don't know. It's not obvious why that number is so high. Now, we can go directly to it. This should not work, because we don't have any ingress that actually tells it that slash should go to that. And we just have one service of a load balancer that looks at port 7000 for it. Yeah, see? That's really weird. I don't really understand why that's doing that. Okay. All right, so that's weird. Let's keep going. Okay. Unfortunately, there's an error in this app. If you click add a book, did I? So if we click add a book, 50% of the time. No. There we go. Kubernetes can detect a service failure from Kubernetes perspective. It looks like everything's fine, but you need application. So we got it the first time. Okay, now we need to add LinkerD to this service. Now we need to add a LinkerD to the service. These options do something like this. kubectl with the namespace of book app, deploy the YAML file, inject LinkerD, and apply that. This time around, I'm going to just run these commands before the actual apply to see what actually goes on. So as you can see, it's all a lot of text, but I think the most important part, there we go, annotations, LinkerD inject enabled. And LinkerD. Okay. So we can go the whole way now. There we go. So we reconfigured the authors, books, traffic, and web app now. And it has been injected. Okay. So if I go to the dashboard here, here's our book app here. And our mesh deployment. I'll make this a little bit bigger for y'all. Okay. And we can see success rate. The pods are doing what we expected. Ooh, here we go. We can immediately identify that, ooh, things are going bad. Everywhere things are going bad. So the request per second is causing real problems. Curious to see what this does now. We actually have a, oh, look, check that out. We got a real-time graph of how the mesh actually comes together. Now that's cool. Istio has this also, but it's not as clean by any standard. Again, I keep going to say, it just feels like this has been UX, the UX of this, or the user experience of this is so much better than Istio. It really is. Like, I see exactly what's going on throughout everything. It just feels like traffic comes in, goes to one of these two, and these two talk to one another. Very easily seen. Imagine having a much larger service mesh here in Kubernetes. You can start playing around with some really, really cool stuff here. I'm curious to see the emoji. Yep, there we go. So the voting bot talked to the web service, talked to voting and the emoji. That's really cool. I like that a lot. Okay. The latency perspective. This is taking way significantly longer than everything else. The web app. That's cool, but you'll notice that the success rate for the web app is not 100%. No. This is because the traffic generator is saying new books. You can do the same thing and push your success rate even lower. Click web app on LinkerD dashboard to live book debug session. Okay. Oh, nice. Oh, that's really cool. It actually is what's going on at that moment. Oh, that's really cool. You'll now be looking at the GTW web app service. You'll see the web app taking traffic from the traffic, the load generator, yep, and two outgoing dependencies of books and authors. Okay. One service is pulling from another. Yep. The failures depend on the service being exactly what's causing the errors the web app is returning. The errors, as your user can see really quick. This book service is also failing. See a live list of that. So, being that we know authors is okay, but books is having a problem. Aha! Do we see anybody trying coming from the web app server going to the book services failing a significant percentage of the time? That does explain why the web app is throwing intermittent failures. Let's click on that. Oops. I'm supposed to click on the other icon. There we go. This guy. The actual response stream. Yep. It's surprisingly easy to intervene always on a single route. You are seeing everything detailed on board point explaining. So if I click on okay. So it's doing what we expect it to. To understand the root cause, we use live traffic. For some issues it's great, but what happens if the issue is intermittent and it happens in the middle of the night? Service profiles provide LinkerD with some additional information about your services. These define the routes that you're serving, among other things, allowing for collections of metrics per basis. With Prometheus storing these metrics, you'll be able to sleep soundly and look up intermittent issues in the morning. One of the easiest ways profile setup is using existing OpenAPI Swagger specs. These demos publish specs for each of the services. You can create services app by running that. Okay. So what I will do is I will open and run this. So it fetches the Swagger specification for web app, takes the spec and converts it into service profile using a profile command, applies the configuration to the cluster. Okay. While on the install and eject profile is pure text option, check the okay. So it actually pulls out all that information. Cool. The name refers to the LinkerD and Kubernetes service. LinkerD is host header requests. Routes are specific or special conditions. Give a method get example regular mix. Okay. To get profiles for authors and books, you can run the following. As you can see, the authors and books Swagger changed. Okay. Ooh. Did not like that. Error from server, error creating a standard in admission webhook. SC LinkerD divided across service profile authors. Has no routes. Maybe I forgot the whole thing. Okay, and then we're gonna do this guy. Okay. Different how it works is you go on inquiry tap. Each web request will show up in authority or host header and is being sent and path weird. Okay. Whoa. That's a lot of information. This will watch for live requests following the web app looking something like this. Yep. You can see it's the correct host. Path contains the name of the route. So path is the authority is right there. Books. So if we're looking at this one, authority books, authority web app. This metrics are a live part of LinkerD routes command instead of LinkerD stat. To see the metrics of cumulative so far, run this. It does not like this one or posting to books, it seems. Or editing books, it seems. Okay. There we go. So this will show all the requests and routes originating from the web app deployment designed for the book service. Similarly, these are using the tap and top views in the debugging session. The root cause is immediately apparent. So it is failing at what I was thinking was, yep, the books for the post and the put. As it can take a while to update the code and roll out the new version, let's tell LinkerD to retry the request with a failing endpoint. This will increase request latencies as requests will be retried multiple times, but not require rolling out a new version. This application's success rate requires books to be authors to be service poor. See the metrics run this. Yep. Basically never works. There's one thing clear that all requests from the books to the authors, the head authors route, those routes requests are failing about 50% of the time. To correct this, let's edit the author's service profile and make those requests retriable by running you want to add the is retriable to the specific route. It should look like this. Is retriable true? After adding the service prop, the LinkerD will make return requests to the route automatically. We'll see nearly immediately produce by running this. There we go. Number is going up. There we go. All right. Now let's play around with some timeouts. LinkerD can limit how many long you wait before failing outgoing requests to another service. These timeouts work by adding another key to the service profile configuration. To get started, let's look at the current latency request from books to that. Request from books to put service. Retries and fails call service. For the purpose of this demo, let's set 25 cents clause for the route. All right. All right. Oh, interesting. So what we did is we created some timeouts. We created a retry. And we also got real information about our systems. So let's go ahead and clean up. And we're done. Okay. So I've got to say, in the grand scheme of things, LinkerD is very impressive. I genuinely understood what was going on throughout this whole process. It just, as Kieran Smith said, it just worked. Like, that's legit. All of a sudden, things just kind of came together, and it was exactly what I needed. I'm looking for that specific tweet, but I'll just like it from there. There you go. Because that's true. It really is truly observability right side of the box. It just did its thing. I am very, very impressed by this thing. I don't really have much else that I was going to go over. I just wanted to sit down and actually finally walk through the tutorials and the plans. I'm just about at an hour and a half, which is probably a good place to stop anyway, being that this was all I was going to go over today. On Friday, so today is July 30th, so on August 2nd, I will be back on the stream where I'm going to be building a Elasticsearch cluster from the ground up with a good friend of mine, Thomas Kate. I have played with Elasticsearch and consumed Elasticsearch before. Hell, I've even installed it a few times, but I've never actually really sat down and tried to learn it. Kind of like what I did here, which was I really did play with LinkerD to finally really understand where the advantages of it is. So this Friday, I will do it. I will also post this to the YouTube channel that I have, which is JJ Asgar, same as with my Twitch stream that hopefully you've seen this from. And I really hope you've learned something, and I hope this is valuable to you. I do this because I honestly have to do this because I have to learn this stuff. And then second, when you see me on stage and I'm presenting and talking about these things, these are the things I run into. These are the things I have to learn and really bang my head against to wonder, why is it doing this? The presentations, when they go right, they seem like they're just too easy. This stuff is not easy. And that's kind of what I wanted to get out through these streamings. Is this was me for 90 minutes just trying to understand the advantages of LinkerD. So hopefully, again, like I said, you'll learn something. I'm very, very accessible. Never hesitate to tweet out at me. And I hope this has been good. So thanks for watching, and I'll catch y'all on Friday.